Hello and welcome. In today's video, we are going to cover Chapter 3 Protocols and Models of the CCNA Introduction to Networks. I'm going to explain the protocols and the rules that actually govern the computer communication, as well as the TCP/IP suite and the OSI reference model. I'm going to show you also how the TCP protocol is used by devices when they communicate using a packet sniffer using Wireshark. We're going to also learn the benefits of the OSI reference model. Also, I'm going to cover in detail the encapsulation process and what exactly happened behind scene when a computer communicates using the OSI layers. PDUs encapsulated into segments at the transport layer, packets at the network layer, and also frames at the data link layer. So let's get started. As you can see, I talked about the objectives, so we're going to learn some rules, the rules actually that computers use in order to communicate. For example, a human being, in order to communicate, we need to agree upon a couple of rules like the language we communicate with, okay? For example, English language. In this case, then we can understand each other. Exactly the same with computers. They need to agree upon a language. The language computer communicates, as you may know, it's binary. And then we're going to dig deeper into the protocols necessary in the network communication protocols, for example, HTTP, DNS, DHCP, and so on and so forth. We're going to talk about the protocol suite and how it's used. I'm going to even take it a little bit further. So I'm going to show you exactly what TCP looks like and how it's used in computer communication. We're going to talk also about the OSI model, the OSI reference model, and we'll go over the layers of the OSI model and what's happened exactly at each layer. We're going to also elaborate and dig deeper into the encapsulation process, and we're going to see what's happened exactly when computers communicate together behind scenes. So let's actually get to it, okay? So rules of communication. So as you can see here, there will be a source. So in order for computers to communicate, there must be some source, okay, computer. So for example, let's say here we have a computer. This is a PC1 and communicating with the server on the other side. So there must be a sender computer, okay, sender computer, and the receiver computer. So the sender and the receiver. There must be also some channel or some media. So that's the Ethernet connection, fiber optic, wireless media, and so on and so forth. So let's go forward. So as you can see here, the exact same communication happen. I mean, in human being communication, so there is a message coming from source, going to destination. Exactly the same with computers. So there must be some source, okay, generating the message, sending it to the destination, and there must be also some medium in the middle to allow the communication to happen. Network protocols requirements. So the protocols requirements, there must be some message encoding. So have you ever thought about, sending an email? So when the email gets to the wire, when it leaves the network card and gets into the wire, how the email can go into the wire. So there must be some encoding, okay? So encoding means that translating digital to analog and analog to digital, translating email to bits, so the bits, they can actually travel over the wire. Message formatting and encapsulation. So message format is basically the message format, what format the message is going to use. And encapsulation, we're going to dig deeper into the encapsulation later on. So it's like adding headers and trailers to the data itself to identify the data and also to prioritize the data and so on and so forth. The message size, as you can see here, so the message size is how many bytes. For example, the maximum transmission unit is 1500 bytes, and if the packet exceeds that amount of bytes it needs to be fragmented. Okay, so the message size right here, and then the timing of the message, that's also called the delay. So the amount of time that the packet will take from the source to reach the destination. So if it will take little delay in case of voice over IP or video conferencing, then the packet wouldn't make it. The message delivery option, so how the message is delivered, either using TCP or UDP. So UDP uses reliability, so the message either used send reliably, means that the other side need to send an acknowledgement. So in case of using, for example, let's say we're using TCP. So we have a client here and we have a server on this side. And let's say we are using the TCP protocol. So basically, TCP protocol, if the client send a message, then the server, when gets the message, he needs to send a sequence number for next message plus an acknowledgement. That's actually, okay, the TCP. So reliability and acknowledgement and sequence numbers. Okay, we'll get to that later on in this course. So let's actually move forward. So as you can see here, the message formatting and encapsulation, why we need encapsulation, why we need to add some headers and trailers to the data itself. We need to do that because if you want to send, for example, a package, as you can see, a package via mailbox, for example, to somebody elsewhere in the world, then you need to actually write your address, the sender address, and the recipient address in order for the mail or for the package to make it to destination. And in case the package didn't make it destination, it will come back to the sender. Exactly the same concept applies when in computer communication. So what exactly happened? So the data itself. So the data itself is actually added some identification headers, if you will, or trailers. So they are added, for example, the source and the destination IPv4 address. Those are the addresses to identify the sender and the destination. Okay, so let's go forward. So message delivery options. So we have a couple of message delivery options. We're talking about the, we have the unicast, as you can see. So the unicast is one-to-one communication. So when computers send a message destined only for one computer or server, this is one-to-one communication. As you can see, the source and the destination. And then we have multicast, so one to group, not to everybody, only to certain group. And then we have a broadcast. For example, the ARP protocol uses the broadcast. So when this computer want to communicate using our protocol to request the MAC address of a PC, it will send a broadcast to everybody, bothering all the PCs, okay, telling them, hey, who has this IP? I need your MAC address. And it's gonna actually disturb all the computers. That's why the broadcast is not something good, okay, in network. So let's actually move forward. So I'm gonna actually show the slide again. So let's actually move forward. So actually, yeah, we were here. So let me go back, message timing. So yeah, we talked about unicast, multicast, and the broadcast, okay? So protocols, let's actually see what are the protocols that actually used in network. So we have network communication protocols. For example, DNS is network communication protocol, okay? For example, let's say DHCP is also network, okay, a protocol. For example, SSH, we could consider it as network security protocol because we use it to remote access devices. Telnet, VPN, for example, is a protocol that operates at add layers of security. So it uses encryption. and so on and so forth. And then we have routing. So routing protocol is the process of routing traffic from source to destination, like OSPF, like RIP, and so on and so forth. We're going to actually get to the routing protocol in the part 2 of the CCNA curriculum. Service discovery, CDP, for example, this is one of the protocols. Cisco Discovery Protocol is also used in service discovery. So yeah, those are all protocols used by application, either on network or security, and so on and so forth. Network protocols function. So some of them actually, they provide logical addressing, like the IP and the routing, so addressing. And then reliability, the function reliability, basically some of them, they provide reliability, like the TCP. So TCP provides reliability, okay? Flow control, some of them, they provide a flow control, like TCP windowing, sequencing actually provides sequence numbers. So if the packet is defragmented and sent over the wire, so the other side or destination need to resemble the packet again, so there must be some sequence numbers. Each packet is marked with sequence number, and also for the acknowledgements, the destination need to know what packet to acknowledge. That's why we use sequence numbers if we are using TCP. Error detection, so error detection basically happens at the data link layer, as we're going to see, and after a while in the OSI model. It's actually using frame check sequence to detect if there are errors that are caused by collision or bad cabling, bad network adapter, and so on and so forth. Application interface, process-to-process communication between network application like DHCP, DNS, and so on and so forth. So, yeah. So protocol suite. Basically, we have one protocol called TCP/IP, is designed by the DoD, Department of Defense of United States, in late 70s. So, and those are the layers of the TCP/IP. You need to remember the layers of the TCP/IP and also the layers of the OSI model. So as you can see here on the TCP/IP, we have 4 layers. Or 5 layers, I should say, sorry. So we have 5 layers starting from the application layer. And we have the transport layer, the internet, and network access. So the TCP/IP suite is actually gathering all the application layers. So the OSI actually divides the application layer into 3 protocols that we're going to mention later on. The transport protocol remains the same. I'm going to elaborate on the application. Basically, it's all the protocols that provide a graphical user interface or terminal window to the end user. It's called a protocol at the application layer. So those are all application layer protocols, as you can see here. And then we have a TCP versus UDP. So TCP is for reliability, and UDP is connectionless, but is fast to deliver. It's used at the transport protocol plus the port number. And at the internet protocol, we have a couple of protocols like IPv4, IPv6, ICMP, used by the ping and trace route. And at network protocol, we have the Ethernet, we have ARP, we have wireless LAN, and so on and so forth. So that's the TCP/IP, and you need to remember the TCP/IP protocol for the exam, okay? So as you can see here at the application layer, for example, HTTP. If we're using HTTP, then at the transport layer, the transport layer adds a TCP for reliability plus the port number. As the data move down one layer, at the internet layer, the IPv4 or IPv6 is added to identify the sender and the receiver. And then at the network access, we could use Ethernet, we could use wireless, we could use either media, okay, for the packet to make it to the destination. So I want to actually emphasize on the TCP/IP and to take it further. So let me show you actually how TCP/IP works. So I'm gonna actually open a web browser here and let me show you how TCP/IP works. So I'm using Eve NG right here, as you can see. So what I'm going to do right now, I'm going to actually capture some packets on the switch. So I'm going to use packet capture, and I'm going to capture packets on Ethernet 0/0. So I'm going to open Wireshark. And let's see if we get some packets that actually can demonstrate the TCP/IP protocol. So yeah, so I think sure enough. So I'm gonna stop my capture right there. So yeah, we get some packets in here. Gonna stop my capture, and then we're gonna go to the DNS. If I double click on this packet right here, as you can see, so that's exactly the TCP/IP protocol. So we talked about the application layer on the top, and then we have the let me actually move this window down, and then I'm gonna actually smoosh this window a little bit like this. Okay, and as you can see here, so yeah, as you can see, we have the application layer. So that's the application layer starting right here. So this is a DNS query. As you can see, it's question DNS. Actually, this computer right here is sending, this computer right here is sending, this computer right here is sending a DNS request, okay, to the switch, and the switch receives the DNS request. It's a query. That's the application layer protocol, and then it's using the user datagram protocol. It's using UDP, okay, using UDP for at the transport layer. As you can see, the application layer, the transport layer is using UDP for fast delivery, because DNS uses both the TCP and UDP. Okay, so for the query, it's using UDP for fast delivery, and then the source port number, which is a random port number, and the destination port number, which is well-known port number 53. That's the transport layer. Okay, and then as we move down one layer here at the internet layer, we're gonna find the the IP is added, encapsulated, so the data is encapsulated with the UDP port numbers, and then at the network layer, the data is encapsulated with the IPv4, as you can see, Internet Protocol version 4 at the internet layer, and then the source IP and the destination IP. So the source is coming from the PC1 and going to the DNS server on the internet 8.8.8.8, as you can see right here. At the network access, what we are going to find here, we're going to find the MAC addresses, the source and the destination MAC address. And this is actually the 5 layers of the TCP IP suite. So we are starting from the application, and then we have the transport layer, and then we have the internet layer, and then we have network access layer. So this is exactly the TCP IP and how it's used by computers on the network. So I'm going to close this window and move on. Okay, so yeah, so let's actually move to next slide. So as you can see here, the web server encapsulates and sending a web page to the client. So this is there is actually 2 processes. So there is encapsulation and then de-encapsulation. So as you can see here, when the client actually the client actually tries to encapsulate the data. So at the application layer, we have the data, plus at the transport layer, we add the TCP. At the internet layer of the TCP IP, we add the IP source and destination. And at the network access, we add the Ethernet MAC addresses, the source and the destination. So when the data leaves the network card going to the wire, it will be encoded as bits, so it can travel over the wire. When it reaches the other side, in this case the web server starts decapsulating, okay, those headers and trailers till eventually it gets only the data, and that's the process of encapsulation. We're going to dig deeper into it later on after a while, okay, using TCP IP using the OSI reference model. So as you can see here, the OSI model divides the application layer into 3 sections, as you can see here. Okay, so we have, instead of having the application, we have the application. And the application, basically every protocol that operates at the application, like when you open a Gmail, for example, and you write an email, that's the application layer, okay? And then presentation is the format of the data itself. Like if you are going to send an email with images like JPEG, PNG, and any format, XML, HTML, that's the format of the data itself. And then the session layer, when 2 computers establish the session. So in case we're using web browser, for example, and user reliability, then the 2 computers, they need to actually establish what is called a TCP they need to establish 3-way handshake. So they need to shake hands before they start the communication. That's the session. Let me show you the session in action using CMD. So I'm going to fire up my CMD, and then let me show you how the session looks like. So if I do netstat -a or -a right here, and then let me look for some, okay, so we get some HTTP right here. So as you can see, this is actually, the first column is for the protocol used at the transport layer. In this case, because we are actually requesting a web page and establishing a session with a server on the internet using HTTPS, then we need to use a secure and reliable protocol, TCP, for reliability and acknowledgement and sequence numbers and so on and so forth. We will get into that later on in chapter 14 in the CCNA curriculum. So as you can see, we're using TCP for reliability, we're using the source IPv4 address, and then source port number, which is a random port number. And then we're using the remote IPv4 address of the remote server. And then the port number or destination port number is HTTPS, or sometimes you may see 443. That's exactly the port number of HTTPS. HTTP uses port 80. So yeah, you will actually need to get familiar with those port numbers, especially the common and well-known port numbers that are used in networking. And the session, as you can see, it's established. Okay, so that's exactly what happened in the session layer. So let's move on here. At the transport layer, basically, what exactly happens? So when the data make it to the transport layer adds the TCP in case of HTTP or web browsing. It adds UDP in case of DNS or voice over IP video conferencing. Then it will use UDP for fast delivery. Okay, and then at the network layer here, we are actually talking about IPv4, IPv6, and ICMPv4 and ICMPv6. ICMP stands for Internet Control Management Protocol, used by the ping and the trace route for troubleshooting. Okay, so at the data link layer, we are talking about MAC addresses, so source and destination MAC are added. And then we're talking about Ethernet, wireless LAN. We're talking about other protocols that operate at the data link layer. As the data and the PDU, or the headers and trailers, make it to the physical layer, then everything is translated into bits and sent over the wire. So I'm going to open here a black screen, and I'm going to show you what exactly happened behind scenes. So let me a black screen here, and then I'm going to actually show you what exactly happened behind scene when a client computer requests a web page. It's good to know, and also it's necessary for exam to understand what exactly happened behind scenes. Let's say we have client computer here. So let's say we have a client here. This is a client computer. And on the other side, we have let's say a server, okay? So this is a server, okay? So the OSI layers are starting from the layer 7, the application layer. So here we have the application. And then this is layer 7. So I'm going to write 7 in here. 7. Okay, 6, the presentation. So presentation, and the layer 5 is the session layer. So the session layer. Layer 4, transport layer. Transport. And then layer 3 is the network layer. By the way, to remember those layers, you could start from the bottom up using a phrase called "please do not throw sausage pizza away." So this is the data link. And then here we have the physical layer. So layer 1, sorry, I need to go back to my black screen. So let me go back to my black screen. Okay, so black screen right here. Let's actually show. No, it's not showing here. Yeah, I'm sorry for that. So, but it's okay. We can do it twice. So, you know, repetition can makes perfect. So let me go to the black screen. So as I mentioned here, we are talking about the sorry guys again. So what I need to do here, so let me do one thing here. So I can just open Paint, or let me do something here. Let me open Paint here. Paint. Okay. Sorry guys, and here we go. So yeah, let's actually maximize this window and maximize it more like this. And then we're going to choose a color in here. So let's use black color, and then we're going to use pen, and then let's actually write right here. So yeah, so as I mentioned here, we have a client computer, and the client computer is going to communicate with a server on the other side, right? So this is a server. It could be Google server, for example. And then right here, we have the 7 layers of the OSI model. So we have the application layer. We have layer 6 is the presentation. And layer 5 is the session layer. And layer 4 is the transport layer. You need to remember those layers on the top of your head in the exam. They are very important. So expect like 3, 4, 5 questions regarding TCP IP and the OSI model. So network layer here, layer 3, network layer. Network layer actually is the where the routers operate, and layer 3 switches. Data link layer right here. Data link layer is layer 2. This is actually the function of the switches, layer 2 switches. And then at layer 1, we have the physical layer. So at the physical layer, we are talking about bits and electrical signals. And excuse my writing. So what happened when this computer here tries to communicate? So at the application, we have the data. Let's say we're communicating using HTTP. So you type google.com. Okay, so google.com on the client, and you have the data right here. So as the data move, let me actually change my color, and also I'm going to use the let me actually use the something like this. So as the data moves down one layer, here we have the format, so data format. Here we have the session, when the computer established the session, and the transport layer is the most important, layer. That's why the TCP IP gathered all the 3 layers into the application layer. So we have the data, and then we add at the transport layer, we add a TCP transport layer header. And at the transport layer header, we have the TCP or UDP. So in this case, we are using web pages. So we're requesting web page, then we are going to use TCP for reliability plus the port number, either 80 or 443 for HTTPS that uses encryption. Okay, as the data and the TCP at port 80 moves down at the network layer, another header is added to the PDU. So this called PDU, and at the transport layer, it's called a segment. And you remember those terms and expect a couple of questions regarding segment. The packet at the network layer, packets are talking about packets, and at the data link layer, we are talking about frames. So switches, they forward frames, routers, they route packets. So at the network layer, we add a source and the destination IPv4. And then as all the PDU moves down here, okay, so the data itself and those headers moves down. So at the data link layer, the frame check sequence and as a trailer, and the header is added also to the data. So we have the data itself, we have the transport layer header. I'm gonna just write T for transport layer header, and then the IP header at the network, and then at the data link layer, we are gonna add the source MAC and the destination MAC, okay, destination MAC address, as well as frame check sequence. So frame check sequence basically detect if there are errors on the frame. So error detection happen at the data link layer. This is a very important concept in the exam, guys. And the error correction happen at the transport layer. So how can the transport layer correct errors? By resending, okay, segments again to the destination. How it knows that the packet didn't make it? Using sequence numbers. We will get to the sequence numbers later on at chapter 14 of the CCNA curriculum. So this process right here is called, let me change my color, let me use black color or any other color, let's use this color here. So this process here is called encapsulation. So you know what is encapsulation, okay? So the encapsulation process is adding, let's say, adding capsules, if you will, okay? This capsule right here, it's added. And then at the network layer, we add another capsule with the IP source destination. At the data link, we add another capsule with the destination source and the destination MAC, plus the frame check sequence trailer for error detection. And then everything as they leave the network card going to the wire, they need to be translated into bits and, okay, 0 and 1, so they could actually go over the wire. And this is the process of encapsulation. So what happened, let me clear the gibberish right now. Let's see what happened when the server actually receive the, let me use this one here. I'm gonna, this is encapsulation. So what happened when the server actually, when the data, let's use the pen now. So let's say we have down here, we have a switch, okay? So after the data actually leaves the wire, going to the switch, we have routers, and we have the router, local router, and then we have ISP router, then we have probably a switch in here, okay? And then the data will make it to the server. So when the server gets the all the PDU, so what it's gonna do with the PDU, so we have the data with D, we have transport here, we have the IP, we have the MAC address, okay, and we have the FCS, frame check sequence. So the server will start stripping, okay, he will actually check, okay, there are no errors, and then move to the MAC address. He will see its own MAC address as destination address. He will strip the header away, throw it away, and then as the data moves up at the network layer, he will strip actually the IP header, okay, away, and then at the transport layer, he will verify the TCP for reliability. So he need to know that he's going to send an acknowledgement and verify the port number, because this server here might be an email server, okay? Might be an email server, might be an FTP server, might be, syslog server. So he need to know what service the client is trying to access, okay? So in this case, he will verify, find out that the port 80 is used. So he knows that the transport layer TCP is used and the port number 80. So the client is requesting a web page, and eventually the server will get only the data itself. This process is called de-encapsulation. So de-encapsulation. So encapsulation, decapsulation, and the process happens again and again and again between the sender and the receiver. I hope this has been informative for you, and I would like to thank you for viewing.